we have looked at two variables to see if they are independent. Now we're going to just look at one variable and see if it is what we would expect. So let's get into it. In this lesson, we will cover the goodness of fit test. We will do a few examples. We will look at some police killings in 2015, and we will do some chi-squared goodness of fit tests in R. Chi-squared goodness of fit. How good is that fit? Let's say I'm trying to test some hypothesis about the US population. I want to be sure to get an accurate representation of the race and ethnicity of the United States. I take a sample of 100 UT students. Will this sample be representative? Will it be a good fit? Think back to our sampling example and some of the issues we had with that. Remember that UT's population was over and underrepresenting certain races and ethnicities. So how do we answer that question? We can do a chi-square goodness of fit test like the chi-square test of independence, but now we are only dealing with one categorical variable rather than two, and we can test the proportions that we observe. So there are two different situations here. We can test if they are equal proportions, like let's say sex in the population, we would expect 50% male, 50% female. It's actually a little different than that, but it's an example. Or unequal proportions. So maybe the age of the workforce in the US, we wouldn't expect all the different age groups to be all in the workforce, but we would see if certain cities, for example, have the same number, the same proportion of people we would expect of different age groups to be working. Here are a few more examples, but there are many more out there. Do the proportions of admission applications to UT from different parts of the state match the proportion of people that live in that area? Or at a wedding, based on people's preferences, what proportion of songs should be waltzes, dances, and cumbias? Are there equal proportions of Skittles colors in a bag? Are there equal proportions of men and women at UT? What kind of goodness of fit questions can you think of? As always, we need to state our null and alternative hypotheses. And as usual, our null hypothesis is that everything is cool and normal, that all the proportions are either equal, so 50-50, or they're equal to some known proportions. We'll see an example of that shortly. The alternative hypothesis is that the proportions are not the same or they do not follow this particular pattern of proportions that you would expect. So let's try it. You go out and ask 120 Netflix and chill people to see if there's any preferences for genre of movie. Use the goodness of fit test at alpha of 0.05 to test this. So we have four different categories here. What would you expect them to be if the null hypothesis were true? You would expect 25% each, 1/4. You would expect 1/4 of people to like action, 1/4 to like comedy, 1/4 romance, 1/4 horror for our null hypothesis because we assume that they are all equally represented. So if you were to take the 120 responses and divide by 4, because there's 4 genres, you would expect to see 30 in each category. So here's our information. We have our null and alternative hypotheses. Step 2, 0.05. Step 3, we get our degrees of freedom. We have 3 in this case. And we get our critical value, which is 7.81. Now we use the same not so pretty formula to get our chi-squared statistic, and we end up with 2.2. So what does that mean? It was not greater than our critical value, so we are going to fail to reject the null hypothesis. What does that mean? That people tend to watch the different movie genres in equal proportions. People don't favor one movie genre over another. Let's try another one. Since we use college students for a lot of social science research, thank you, I want to know if the convenience UT sample I took is a good fit to represent the USA. Conduct a chi-square goodness of fit test with the data below at the 0.05 level. So here is what we observed at UT. We had 41% white, 4% black, 21% Latinx, 19% Asian, and 15% other. This is what we would expect in the US population. 61%, 13%, 16%, 5%, 5%. Do you think that this is going to be a good representative sample for this? Do you think it's going to fit well? So we're going to say that the sample of UT students matches the national averages for race and ethnicities in the different proportions, and the alternative is that they do not. 0.05, chi-square test, goodness of fit, and we have a critical value here of 9.49. If we put all that into our chi-square goodness of fit equation here, we end up with 73.55. So we get to reject that null hypothesis because 73.55 is definitely bigger than our critical value. So what is that saying? That our UT sample does not really match the USA's racial and ethnic demographics. Let's try one more by hand. Let's test whether all of the colors or flavors. I just recently learned that Skittles don't come in different flavors. They're just different colors, and it's all in your mind. I feel lied to. Anyways, test if all those colors come in equal proportions. So I took a big bag of Skittles, counted them all meticulously, and there were 365, and these were the numbers for each color. Now, if you take the total number and divide by 5, which is the number of colors there are in a bag, you would expect 73 of each color around. So our hypothesis that all the colors or flavors of Skittles are found in equal proportions, and the alternative is that they are not. We are testing at the 0.05. We are doing a chi-square test goodness of fit. We have 4 degrees of freedom, and we have a critical value of 9.49 again. So we put that into our equation here, and we end up with 8.47. Nope. We're going to fail to reject that one. Because our chi-squared statistic does not pass our chi-squared critical, we fail to reject the null hypothesis. There is no reason to suggest that Skittles colors are not represented in equal proportions in the bag. You could use this to test if ever you got some sort of bag of candy and maybe they were gypping you and skimping on some of the higher grade candies. Goodness of fit test. Check it out. Now we're going to look at a more serious example with police killings in 2015. For decades, we have heard cases when a police officer kills somebody in the line of duty. Sometimes these actions are justified and sometimes they are not. Some hold the belief that certain minorities are targeted more frequently than the white majority. Others dispute this and believe that no racial or ethnic group is disproportionately targeted. This is going to be our null hypothesis. Let's use Statistic to see if we can provide some evidence for one side or the other. So first, we are going to state our null and alternative hypotheses. The null hypothesis is that police killings occur in equal proportions to the racial and ethnic demographics of the United States. So we have 6% Asian, 13% Black, 16% Latinx, 1% Native American, and 64% non-Latinx white. Our alternative hypothesis is that they do not occur in equal proportions to the racial and ethnic demographics of the US. Our alpha level is 0.05. We're using a chi-squared goodness of fit test. We have 5 groups minus 1, so we have 4 degrees of freedom. We have a critical value of 9.49. So I'm going to do this example in R because this is a real data set. It is in Canvas, but you can also go to these links to look at the original data set. First, I'm going to read in the data. Then here, what this function is doing is I'm filtering out any cases that did not have a race or ethnicity listed, so it was listed as unknown. I'm taking those out. And here I'm creating a table that's going to show me how many cases were Black, Asian, Latinx, etc. And I'm going to save that as an object. Now right here, I'm going to define the proportions that we would expect. So we would expect 6% to be Asian or a certain percentage to be their corresponding race ethnicity. Now to actually run the test, we are going to do a chi-squared test. I'm going to put in that table I created right here. That table again is just a list of all the actual tallies, the counts, the observed counts for each race and ethnicity. I'm going to put that right there. And P is going to be the proportion we would expect. So I'm going to put this object right here. So if you run all that and look at the results, we can see that the chi-squared test is certainly significant. We can reject that null hypothesis. The number of police killings for a certain race ethnicity do not match the proportions of the race and ethnicity in the United States. So if we look here, this is our chi-squared test statistic, about 120, which is definitely bigger than that 9 point something that we needed to beat. And our p-value confirms this. It's very, very small. You can also look at the information stored in this object by just clicking on it in R. When you save an object in R that is from a statistical test, if you click on it here in your global environment, sometimes it'll give you options with little drop downs with additional information. In our chi-squared test, we had some additional information regarding observed count and expected count. Now if we look at the observed, we see 236 white, 4 Native American, 64 Latinx, 135 Black, and 10 Asian. Now if we were to just look at raw numbers, it would look like white is being overly represented, but there are more white people in the United States. So if we then look at the expected counts, we would expect 289 white, which is a little bit less than what we saw. we would expect 5 Native Americans, which is 1 less than what we saw. 72 Latinx, few less than what we saw. 59 is what we would expect for Black, and we saw 76 more than that. And we would expect 27 for Asian, but we saw a little bit less than that. So it looks like we can conclude that the police shootings do not occur equally for each racial and ethnic group. This is just one example of how statistics can tackle some pretty tough questions, and this data set was available freely online. I highly encourage you to go out there and look around and see what else you can find, but always check your sources and make sure that they're credible. How to square goodness of fit in R some more. So here is how you could do the chi-squared goodness of fit test for all of our other examples that we did with the movies, the demographics, and the Skittles. And we end up with the same conclusions, that movie genres are watched equally, our UT sample does not fit the US population, and Skittles colors are equally represented in a bag. Now I highly encourage you to try something a little bit more exciting, like go and look at that police data set. It's pretty big, it has a lot of other variables in there that you could maybe try to look at and do some statistics on. Give it a go.